afternoon, everyone. My name is Oluwabusayo Olukoya, and you can also call me the Global Teacher. Today, we'll be talking about applications of rules of divisibility to number-based system. Applications of rules of divisibility to number-based system. So last class, we dealt with how to apply the rules of divisibility to modular arithmetic. For today's class, we're talking about how to apply the rules of divisibility to number-based system. So let's solve this question together. Convert 8407 base 10 to base 3. So you have 8407. You have your remainder here. So since you are converting to base 3, you have 3 in front. So 3 in 8, you have 2, remainder 2. 3 in 24, you have 8. 3 in 0, 0. 3 in 7, 2, remainder 1. 3, so you bring out your 3 again. 3 in 28, you have 9, remainder 1. 3 in 10, you have 3, remainder 1. 3 in 12, that's 4, remainder 0. 3 again. 3 in 9, you have 3. 3 in 3, 1. 3 in 4, 1, remainder 1. Bring out your 3 again. You have 3. 3 in 3, 1. 3 in 1, you have 0. So have the 1 to the other one to get 11. So you have 3 in 11, you have 3, remainder 2. So bring out your 3 again. You have your 3. 3 in 10, 3, remainder 1. 3 in 13, that's 4, remainder 1. Bring out your 3 again. You have 3 in 3, 1, remainder. So 3 in 3, you have 1. 3 in 4, 1, remainder 1. Again, you have 3. Bring out your 3. 3 in 11. 3 in 11, you have 3, remainder 2. Bring out your 3 again. You have 3 in 3, 1, remainder 0. So 3 in 1, that's 0, since it's not up to 3. So you have your remainder 1 here. So this is what you have when you are trying. This is how you would go about it when you are trying to solve. When you are trying to convert 8407 base 10 to base 3. Now, how do you apply the rule of divisibility here? How do you apply the rules of divisibility here? Now, you are trying to convert to base 3. So that means what you are going to use, you are going to use the rule of divisibility for 3 because you are converting to base 3. Now, the rule of divisibility for base 3 will help you to fact check the remainder you got here. That is, it will help you to know that to know if the remainder you got here is indeed the correct answer. So it will make you to know if the answers you got here is correct. Now, how do you apply this rule? Now, what is the rule of divisibility for 3? It states that a number is divisible by 3 if the sum gives you a number divisible by 3. So that implies that to get the remainder here, we have to add each of the digits of these numbers. We have to add each of the digits of these numbers to verify if the remainder we got here is correct. To verify if the remainder we got here is correct. So let's do that. Now, why are we adding? We're adding because the rule of divisibility states that we should add. And it states that a number is divisible by 3 if the sum of its digits you a number divisible by 3. So we are looking at the sum of the digits of these numbers. Now, 8 plus 4, 12. 12 plus 7, that's 22. Now, and 22 divided by 3 gives you 7 remainder 1. Hence, the one we got here is actually correct. That means we've been able to verify that the one we got here is correct. Now, let's apply the same rule. 2 plus 8, 10. 10 plus 2, 12. 12 divided by 3, 4 remainder 0. So we have a remainder of 0. 9 plus 3, 12. 12 plus 4, 16. 16 divided by 3, 5 remainder 1. So you have your remainder 1 here. The next number, you have 3 plus 1, 4. 4 plus 1, 5. 5 divided by 3, you have 1 remainder 2. Can we see that the rule of divisibility for 3 is helping us to fact check the remainder we got here? So in case you've made any mistakes in getting this remainder, the rule of divisibility for 3 will help you to realize that mistake. Now, 1 plus 0, 1 plus 3, 4. So 4 divided by 3, you have 1 remainder 1. So you have the remainder of 1 here. The same thing, 3 plus 4, 7. 7 divided by 3, you have 2 remainder 1. 1 plus 1, 2. 2 divided by 3 is not up to 3 now. So that's 0 remainder 2. So, and you have 3 here. 3 divided by 3, 1 remainder 0. You have 1 here. 1 divided by 3, 0 remainder 1. So the rules of divisibility for 3 has helped us to be able to fact check the answers we got here as the remainder. So now we are very sure that 8407 base 10 to base 3 is going to give us, to call the numbers from the bottom. So you have 1, 0, 2, 1, 1, 2, 1, 0, 1, 1, 0, 2, 1, 1, 2, 1, 0, 1, base 3. So we've been able to solve this question under number base, and we've been able to use the rule of divisibility for 3 to fact check the answers we got. Let's look at another question. To convert 10028 base 10 to base 4. So we'll have 10028. So this part is going to be for our remainder, and we are converting to base 4. So we are going to use 4. So 4 in 10, you have 2, remainder 2. 4 in 20, you have 5. 4 in 2, you have 0. 4 in 28. So 4 in 2, you have 0. So take the 2 to the other. Join the 2 with the next number. So you have 28. So 4 in 28, you have 7. Remainder 0. 4 in 25, that's 6. Remainder 1. 4 in 10, that's 2, remainder 2. 4 in 27, that's 6, remainder 3. You bring out our 4 again. 4 in 6, you have 1, remainder 2. 4 in 22, you have 5, remainder 2. 4 in 26, you have 6, remainder 2. Bring out your 4. 4 in 15. Bring out your 4. So 4 in 15, you have 3, remainder 3. 4 in 36, you have 9, remainder 0. Bring out your 4 again. You have 4 in 39. 4 in 39, you have 9, remainder 3. Bring out your 4. You have 4. 4 in 9, you have 2, remainder 1. 4 in 2, that's 0, remainder 2. Now, let's use the rule of divisibility for 4 to fact check the answers we got as the remainder here. Okay, what is the rule of divisibility for 4? If you can recall that we learned that the rule of divisibility for 4 states that a number is divisible by 4 if the last 2 digits form a number divisible by 4. That is, if the last 2 digits of any number, if it is divisible by 4, the whole number is going to be divisible by 4. So let's apply this rule here. So we are going to be dealing with the last 2 digits of these numbers according to the rule of divisibility for 4. So we have the last 2 digits here is 28. So we'll simply do 28 divided by 4. So you have 7 remainder 0. So we got the remainder of 0. Now, the last 2 digits here is 0, 7, which forms the number 7. So 7 divided by 4, you have 1 remainder 3, which is what we got here. The same way, the last 2 digits here is 26. 26 divided by 4, you have 6 remainder 2. And which is the same thing we got here. Now, the last 2 digits here is 56. We have 56. 56 divided by 4, 14 remainder 0. 39 divided by 4. You have 39 as the last 2 digits because there are only 2 digits here. So just take the 2 digits that you have here. So that's 39 divided by 4. That's 9 remainder 3. So you have 9 here, which is the only digit. So let's make use of it. That's 9 divided by 4. That's 2 remainder 1. So you have 2 here remaining. 2 divided by 4, 0 remainder 2. So you will see that the rule of divisibility of 4 has helped us to fact check if the answers we got here is actually correct. That we are very sure that 10028 base 10 to base 4 is going to give us, so let's have our arrow up. So it's going to give us 2, 1, 3, 0, 2, 3, 0, base 4. So you have 2, 1, 3, 0, 2, 3, 0, base 4. So it is the number base we are converting to that will determine the rule of divisibility that would apply. If you are converting to base 5, that means you are going to use the rule of divisibility for 5. If you are converting to base 6, you use the rule of divisibility for 6. If you are converting to base 2, you use the rule of divisibility for 2. So it is the number it is the base you are converting to that will determine the rule of divisibility you would use. So let's have the exercise for the week. So the exercise for the week is going to be convert 80191 base 10 to base 9. Don't forget you're converting to base 9. So that implies that the rule of divisibility that you're going to use is going to be in base what? Base 9. It's going to be in base 9. Next class, we'll be moving to another topic entirely. We'll be moving to a new topic entirely. So stay tuned. Have a wonderful week. Bye.